All right, ladies and gentlemen, in this video we are continuing our topic of proving geometric relationships, but specifically the intention or the goal of this video is to learn how to utilize the vertical angles congruency theorem within a proof. We've already talked about how to prove this theorem, so now we're going to learn how to utilize it in an actual proof. So let's take a look at an example in which the vertical angles congruency theorem is utilized. So this says write a paragraph proof, but I know we're going to go ahead and just kind of do a two-column proof for this. I think it shows a little bit easier of a visual for us. So let's take a look at a two-column proof of the following. So let's think about what happens here. We know, of course, off the bat that angle 1 is congruent to angle 4 that is given to us. So angle 1 is congruent to angle 4. And I want to show that 2 and 3 are in fact congruent to one another as well. So let's think about this here for a sec. What can we use in terms of what we know about the situation? Well, the situation tells us that 1 and 2 are in fact vertical angles. And so we know that angle 1 is congruent to angle 2 by the vertical angles congruency theorem. So we know that they are congruent to each other. And we also know similarly that angle 3, so let me go back here and mark this. So 1 and 2 are now congruent. We also know that 3 and 4 are congruent by the vertical angles congruency theorem. And the goal is to show that 2 is congruent to 3. Well, if 1 is congruent to 4, and 1 is congruent to 2, that means that 2 is also congruent to 4. It means 2 is also congruent to 4, and that is our transitive property of congruency. And so now we've also stated that if 3 is congruent to 4, and 2 is congruent to 4, that means that 2 and 3 must also be congruent. Once again, by our transitive property of congruency. Game, set, match. That is what we were trying to prove in the end. We have now shown how to prove that angle 2 and 3 were congruent by the use of the vertical angles congruency theorem and our transitive property of congruence.